on page 653. We are going to start off with a new, this is on your formula sheet, but we're going to prove it, that 2 sine theta is equal to 2 sine theta cos theta. Now, when we look at this originally, everything's already in sine and cos. Everything is already a single fraction because you could write this over 1 and this over 1. We've got a single fraction on both sides. And if everything's in sine and cos and everything's a single fraction and they're not the same, generally we're stuck. And we've looked at strategies of building the other side, but there's already a common denominator here because they're both over 1. So the build the other side strategy is not going to work. And the other thing we would do is factor, but there's nothing really to factor here. So we're really stuck. Now, the key to this proof, the strategy that you need to this proof, relies on some math that you learned a long, long time ago. Okay? I would hearken to say that you maybe learned this, well, you probably already knew it in kindergarten. You might have even known it before you went to kindergarten. So what could that possibly be? Okay, what did you know? What did you know going into kindergarten? Just name some facts you probably knew going into kindergarten. 1 plus 1 is 2. That is the strategy that we have to use in this one. That's brilliant. That is the strategy. 1 plus 1 is 2. Okay? That is the strategy we need to use in this one, because I have right here 2 thetas, and if I go back to my kindergarten strategy that I know that 2 thetas is the same as just 1 theta plus 1 theta, I could rewrite this side as theta plus theta. Okay? Sometimes you don't get these brilliant thoughts because you put out of your mind such easy ideas like 1 plus 1 is 2. Now, if I change it to theta plus theta, what does it look like on the left side? Those big long formulas, right? But now my alpha is theta and my beta is theta. So if I write out the big long formula for sine alpha plus beta, it will be sine alpha cos alpha plus cos alpha sine beta. Of course, the alphas and the betas are the same this time. They're just both thetas. Now we go back to kindergarten again. If I have sine theta cos theta plus another sine theta cos theta, what do I get? 2 sine theta cos thetas. On the left side equal the right side. And we're done. Yes?
Are we ever going to get proofs when we need to use
The strategy 1 plus 1 equals 2?
no, the alpha beta stuff?
Yes, there will be proofs that use the alpha beta. And now we get introduced to a bunch of double angle identities. Okay? And that is one of them we just did. We just proved this first one right here. You could use the same strategy to prove this one, that cos 2 theta is cos squared minus sine squared. And because cos squared is 1 minus sine squared, if I replace this cos squared with 1 minus sine squared and combine like terms, I would get that one. And if I replace the sine squared with 1 minus cos squared, I would get this one. And if I did the same thing with 1 plus 1 equals 2 for tan, I would get that formula. All of these formulas are on your formula sheet. They're called the double angle identities because inside the trig function, the angle is doubled.